section 5.2 in your pre-calculus 12 studies. We're going to use what you did last day with all that transformation stuff, and we're going to put it all together and put it into good use today. Alright? Today, you will need to be able to look at graphs, and then from the graphs, come up with the equations. Okay? This is quite important because this is going to set you up for future success down the road when we do section 5.4. Okay? And then we'll tackle some word problems then too. Oh yeah, your lovely word problems. But that's later on, and today is this. So let's take a look at example number 1. I want you to determine a sinusoidal function for the graph below. Now it says you should try to find one that uses either sine and also one that uses cosine. So I'm going to say there are more than one answer for this graph. I'd like us to try to find one that involves the sine function, and then another one that also involves the cosine function. Now, remember here that sine and cosine are similar, but a little bit different. I like to just do a quick sketch of the graph. I'm going to put it to the side here so that we know what they are. Okay, if you don't need to do them, that's fine, but if you want to, you can. Remember, sine always starts in the middle, then goes up top, comes back down to the middle, then goes to the bottom, -1, and then back to the middle. 1, -1, right? Then we got cosine, a little bit different. Starts up high at 1, goes down, -1, back up to 1. So 1, -1. Notice both graphs have a period of 2 pi. Okay. We're going to have to find a sinusoidal function. Okay, whenever it says sinusoidal function, think this: y equals to a, and then either sine or cosine. Okay, b x minus c plus d. So all that stuff from last day. A stands for the amplitude, b is the phase shift, c is the vertical, sorry, b is not the phase shift, b is the thing that helps you find the period, c is the phase shift, and d is the vertical displacement. Well, what can you find for me? I would say let's take a look at the amplitude first. Okay? I'd also say we should be able to find the vertical displacement. And if you remember that food for thought question from last day, well, if you did it, you know what to do. And if you didn't, well, I guess here is where I spoil the fun for you. How can we calculate the amplitude and the vertical displacement? I'm saying if you know the maximum value and the minimum value, then that's pretty easy. What is our maximum value? From the graph, our maximum value seems to be equal to 3. And our minimum value seems to be equal to -3. Well, if you think about the vertical displacement, that's always in between the max and min value. So the vertical displacement can be found by doing what? If it's in between, that should be just the max value plus the min value and average it, so divided by 2. And that was one of the pieces for food for thought from last time. So I'm saying to you that d equals to 3 plus -3 all over 2. Well, that's just 0 over 2. That's just 0, which makes total sense. It seems like the middle of this graph is 0. Well, how can we find the amplitude? Well, amplitude, of course, is the distance from the highest point to the middle, or the lowest point to the middle, or from last day's food for thought, it would be the maximum value minus the minimum value divided by 2. Okay. In this case, for this picture, the amplitude would be 3 take away -3 all over 2. 6 divided by 2, that gives us 3. And that makes sense too, right? This distance here most definitely seems to be 3. Okay. The next thing I would do is try to calculate the period. The period, once again, is the length, or I'll even say the horizontal length, required to complete one cycle. So I'm thinking period. Length for one cycle. It's easy to find the length of one cycle if you compare the top with another top, or the bottom with another bottom. So I'm thinking here is top with top, right? So it looks like 1, 2, 3, 4, 5, 6 spaces. Well, 1, 2, 3, 4, 5, 6 is just pi. So the period in this case seems to be pi. Okay. I guess I shouldn't box that. Okay. And I'll say period, just compare the peaks. The top, right? Or the valleys. Right? The bottom and the bottom. I could have just compared those as well. Okay? Alright, here comes the hardest one. The hardest one is the phase shift. Phase shift is actually a little bit more difficult because it also depends on which graph or which function you want to use. Okay. Remember how I drew those up here, sine and cosine? What are some of the characteristics of where it starts? Again, sine starts in the middle, where cosine starts up high. So the phase shift, okay, and I'll say the phase shift depends on which function you choose. Okay, so remember here once again, sine starts in the middle, where cosine starts up high. So I'm going to break this up. Okay, if you choose cosine, okay, you want to compare the highest point. Okay, because cosine starts in the highest point. So in this case, the highest point seems to be one of these units over from the y-axis. One unit represents pi over 6. So in this case, I'll say in this example, the phase shift is 1 unit, which is pi over 6 to the right. Okay, that's if you choose cosine. Okay, therefore, I'm going to just continue with cosine first. Okay, so therefore, what we have here is y equals to a, which is the amplitude 3. And notice there's no reflection here, so I'm just going to use 3. Cosine b. Oh, what's b again? Oh, what's b? How do I find b? Well, remember how we had this before? I'm going to just put a little note on the side over here. Remember how the period was always equal to 2 pi divided by the b value? So if I were to rearrange this right now, I could say, hey, the b value times the period equals to 2 pi. And so b just equals to 2 pi divided by a period. Yeah. So using this as my fact, I can now say that since the period is pi, b is just equal to 2 pi divided by pi, which is just 2. So in this case, 2 pi divided by pi, that's just 2. So back to my equation, y equals to 3 cosine 2 bracket x minus my phase shift is pi over 6. And then I'm going to add to it my vertical displacement plus 0. Well, you don't even need to write down plus 0 if you don't want to. Okay, there you go. That is one possible equation. Is that the only one, though? Well, remember how I said the phase shift depends on which function you choose? So what happens if I choose sine? So if you choose sine, what do I want to compare now? I don't want to compare the highest point. I want to compare the middle. Because sine starts in the middle, right? Sine starts up here in the middle. So let's look at our graph now again. And in this case, see how far sine has shifted. So where is the middle? Well, there's a few places you can choose from the middle. Okay, I'm going to use my blue highlighter. You can choose this point here, or you can choose this point here. Okay, which one do you think is better for us? Well, remember, sine starts in the middle, then goes up high. So if I want positive sine, I think this one here to the left, and a big dot, is a better response. Well, that looks like I've shifted the graph not 1 unit, but half a unit over. Half unit over probably is pi over 12, because half of pi over 6, half of pi over 6 is pi over 12. So in this example, the phase shift is half of pi over 6, which equals to pi over 12. And this time we're going to the left. So knowing that now, your equation is y equals to 3, same amplitude, sine, same b value, but this time instead of x minus pi over 6, it will be x plus pi over 12. And there you have it. Done. By the way, these aren't the only two equations I could choose. Okay. Notice how just previously I had another value that I highlighted in blue, not the one to the left of the y-axis, but the one to the right over here. Well, if I chose that one, notice the graph goes down, then up, then back down. Well, that's just negative sine x. That's a reflection in the x-axis. So if I were to be so bold to choose this point, and I'll highlight this now in green, well, that seems to be pi over 6, another pi over 12. So 2, 4, that's 5 pi over 12 to the right. So just to make things even more complicated for you, I'll say if you choose negative sine, you are still comparing the middle, but in this case the phase shift would be 5 pi over 12 to the right. And so therefore, you could have also written down y equals negative 3 sine 2 bracket x minus 5 pi over 12. And of course, there's one more with a negative cosine, but I've run out of room, and so I'm not going to do it. You can try it, and then if you want me to check the answer for you, bring it to me in class, and I'll check it for you. But notice for all of these, the thing that's most complicated is the phase shift. Why is it the most complicated? Well, because these trig functions are periodic, and so you'll see that they repeat themselves time and time again. And therefore, you have lots of different choices you can use for the phase shift, and that's where sometimes people get confused. All right, let's turn the page. Next one doesn't have a graph, but all I do is tell you some information. And I'm saying from this information, you should be able to figure out the equation of the graph. Once again, you need to find the amplitude, the vertical displacement, the period, which leads you to the b value, and finally, the phase shift. Alright, well, I think I said you should draw a sketch for this one, so why don't I draw a sketch? Okay. Dun, dun, dun. Oops. Let's make it nice. Okay. A maximum point of pi over 6, 8. So I don't really know what that is, but let's just pretend this is pi over 6. Let's pretend this point here is 8. So this is my max, pi over 6, 8. And then its nearest minimum to the right is 5 pi over 6. Okay, so that's cool. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. And it's at -3, so 1, 2, 3, probably down here. So that's the point. 5 pi over 6, -3. So I guess the graph looks something like this. Whee! This goes back up. Whee! Anyone know what this value could be? Well, I'll let you think about that. Okay. I guess there's a nice picture of the cosine graph. I guess now I have to just figure out all those things. A, B, C, and D. Remember how I said the vertical displacement and amplitude are the easiest to find? Yeah, so let's do that. The amplitude, if you have the max and the min, it's easy. So take the max value, which is 8. Subtract from that the min value, -3. Divide this by 2. That's 11 over 2, or 5.5. Vertical displacement, very similar. But knowing the max and min values, you could do this. Max plus min. Divide that by 2. How about 2.5? Alright, period is next. Well, I guess I know this distance, pi over 6 to 5 pi over 6, that's just 4 pi over 6. Is that actually the period? It's actually not, because the period is actually double that. That's only from the max to the min. I'm going to go back up to the max for the period. So I guess I should just double that 4 pi over 6, because this is also 4 pi over 6, right? So the period is just doubling of 4 pi over 6. And that would be 8 pi over 6, or 4 pi over 3. Now remember, this is the period, but what we're looking for really is the b value. So the b value is always 2 pi divided by the period. And so we'll take 2 pi divided by 4 pi over 3. That looks messy, so we'll rewrite this as 2 pi times 3 over 4 pi. Remember, dividing is the same thing as multiplying by the reciprocal. That's 2 over 1, so 2 pi times 3, 6 pi over 4 pi. I think that just leaves us with the number 3 over 2. Hardest one, of course, is the phase shift. I told you which graph to use this time. I said use cosine, right? So remember, you want to compare, because we're using cosine, compare the highest point with the y-axis. And of course, this is only true for cosine once again. Okay, sine's different. Native cosine is also different. In this case, it looks like I've shifted the graph pi over 6 from the y-axis. So it looks like it's a shift pi over 6 to the right. And I think now I have everything in place. I've got my amplitude, which is A. Got my vertical displacement, which is D. Got my B value here. And now I have my C value here. It's time to write the equation. So the equation is Remember that format? Y equals to A, which is 5.5. In this case, the sinusoidal function is cosine, so cosine of B, which is 3 over 2, bracket x minus c, which is pi over 6, plus d, which is 2.5. Ta-da! Done. Oh, what's this down here? An extension? Oh, well, similar. Just let me extend it a little bit. What happens if I changed it? If I said, hey, let's not use cos, let's use sine. How would you do sine? Tough call, eh? Well, remember, everything's the same. Almost everything, sorry. The amplitude's the same. That's still going to be 5.5. The vertical displacement's still the same. That's still 2.5. Even the period is the same. 4 pi over 3. And of course that leads us to the b value being 3 over 2. And that's the same. The only difference here is the phase shift. So with the phase shift, I'm going to ask you to once again compare, and because this is sine, I want you to compare the middle with the y-axis and see how far it got shifted either to the left or to the right. Okay, gonna have to move back up to my graph. Where is the middle? Well, if you think of the middle of this graph, we know that the vertical displacement is 2.5. So it's probably going to be in between the pi over 6 and 5 pi over 6. So you're thinking about middle, probably right here. Halfway between pi over 6 and 5 pi over 6, of course, is just 3 pi over 6. So I'm thinking the phase shift here is 3 pi over 6. So it seems to be a shift of 3 pi over 6, or pi over 2 to the right. Okay? So that seems to be enough information. I can start putting together the sign. But before we do that, just make you aware of one more thing. See how right at that middle, if I move to the right, it actually goes down? I thought regular sine should go up. Remember? Y equals sine x, it should go up. But then ours here goes down. Oh yeah, if you said reflection in the x-axis, you're right. So because I use that point of pi over 2 to the right, and okay, I notice that the sine graph goes down before coming back up. That means I also have a reflection in the x-axis. So, with all this now, let's go ahead and put the equation together. Y equals to 5.5, but because you have a reflection in the x-axis, it's now negative. How about sine of 3 over 2, x minus pi over 2 plus 2.5. Ta-da. And once again, that's not the only answer. If I wanted a sign that's positive, of course, in this case, I would be shifting the graph not to the right, but I'd probably be looking for the shift to the left. I'll use black, right? Something like this, and I'm looking for this value here. Okay. I'll let you think about that and see how far that goes. Okay. But if you think about it, see 2 dashes over, right? 2 dashes over. I'll just say down here, and you can think about this too, or using a positive sign I'll let you think about this, but I'll just ask you to write this down if you don't have time to think. The actual phase shift is pi over 6 to the right. Oh, sorry, to the right, to the left. Once again, lots of different possible equations. This is where I, as a teacher, need to do a little bit more work because I have to look at all your possible answers and say, does yours fit? And if it does, of course, I will mark it all correct. Okay, it's time for you to try some yourself. Good luck!